Hello, 5th and 6th grade. Today we are going on to 11.6 in your science book. There is not a chapter to read on this, so you don't need to go to your textbook for this one. We're just in the lab book today. So if you want to take out your lab book and open up to 11.6a, we're going to be doing pages A, B, and C today. So we're going to read this together, talk about what an epicenter is, and then you guys can start doing the work in your lab book. So finding the epicenter of an earthquake. Seismic waves recorded on a seismograph are used to locate the epicenter of an earthquake. Since P waves arrive first, with S waves following close behind, the difference between the two arrival times are used to determine the distance from the seismograph station to the epicenter. A circle is then drawn on the map using the distance as a radius and the station as the center of the circle. One circle must be drawn from each of the three different stations. The point at which all three circles intersect is the location of the earthquake's epicenter. Following the directions below to find the epicenter of a location. So, for number 1, the data table below shows the difference between P and S wave arrival times for 3 seismograph stations. Use the graph on the next page to locate the distance from the epicenter to each of the 3 stations. Find the difference in arrival times for Denver on the vertical or y-axis and follow this line across to the point of intersection with the curved line. Find the distance to the epicenter by reading down from the point of intersection to the horizontal or x-axis. Enter this distance in the distance to the epicenter column on the data table below. Number 2, repeat step 1 for Salt Lake City and Seattle. Record the distance in the table below. Number 3, set your compass. Now, if you have a compass at home, not a compass that you would go in the woods to find direction, but a compass is a mathematical tool where you put a pencil in one side, and it usually is in an A frame, and you have a pencil on one side, and then the other side is a point that you stick on your paper, and you can use it to draw circles. If you don't have one, you could always use a piece of string on a tack, or if you hold the string to your paper and have a pencil on the other end of it and use that, that can work as well. Set your compass at a radius equal to the distance from Denver to the epicenter. To do this, use the map scale located on the map of the United States on the next page. Place the point of the compass on the origin of the scale at 0. Open the compass and set the pencil tip on the distance in kilometers. This is the radius of the circle. Set the point of the compass on Denver and draw a circle around that city using the radius determined in step 3. Make sure to draw the circle carefully. Repeat steps 1, 3, and 4 for Salt Lake City and Seattle. So you're finding the distance to the epicenter from the seismology office, or what did they call it? Station. There we go. Okay, so you have Denver, Colorado. The difference in arrival time between P and S waves were 2 minutes and 10 seconds. For Salt Lake City, it's 1 minute, 10 seconds. And from Seattle, Washington, it was 1 minute, 40 seconds. So on the next map, we are going to be listing and labeling on the map different seismic activities. So you have the distance to the epicenter along the bottom, and you have difference in arrival time of P and S waves going up the side. And then on the bottom, you're going to use a compass the best you can to draw circles to show where they overlap and where that epicenter would be. For 11.6c, analyzing the epicenter, use the data from the previous 2 pages to answer the following questions. Observe the 3 circles you have drawn to locate the epicenter of the earthquakes by finding the point of intersection of the 3 circles. Mark that point with a star. Which one of these 3 cities is closest to the earthquake's epicenter? So that's something you might need to look up to see what the city is. And then we're going to answer the questions following that, looking at the information that we drew. All right. If you have any questions on this, how to graph it, do your best to go through it and how to put it on the graph. We can look at it again. Let's see. Oh, number 3. So on the next page, place the point of the compass on the origins of the scale at 0. Open the compass and set the pencil tip on the distance in kilometers. This is the radius of a circle. Okay, so radius is the halfway across. If you cut a circle in half, the radius would be half of that line. And so that's what you're looking for when you're using a compass. Okay. Once again, as I usually say, see if you can find either Bill Nye or National Geographic or Discovery for kids and look up epicenters of earthquakes and what science is doing behind that. And that's a job all in itself as well, is being in these stations and monitoring earthquakes and sending out alarms and finding data, collecting data for research so that people can be more prepared for earthquakes and have a longer time period of preparation than we currently do. So very interested stuff. If you're interested in this kind of thing, that might be a great job profession for you, to move into study of hurricanes, study of earthquakes, hurricanes, studies of tornadoes. There's so much fascinating stuff. So if you have any questions, please let me know. Do your best, and I will see you next time. Bye.